Hey students, this is part 2 of the video, the unit 2 review, but it's only about function notation. So function notation is whenever you have a format of f of x instead of y equals, and using function notation to answer what they're asking you in function notation. So anytime you have f of a number, write down f of x right below it and understand that that -5 is replacing the x. So if you were to analyze the table for this equation, you're looking for when x is -5, what is the y value? So your analysis can be done algebraically or graphically. If you're doing it graphically, you will go graph this function, 7 minus 4x, graph it, go to table, and find out when x is -5, what is your y value? So here they have 27 as an answer. And if you notice, 27 is an answer as well. If you want to do this algebraically, all you're doing is replacing the x with the -5. So you will be writing 7 minus 4 times -5, and either doing this with PEMDAS. So -5 times -4, that's positive 20, and 7 plus 20 is 27. Or you could also just type it in here as 7 minus 4, parentheses, -5, and then pressing enter. So 3 different ways to answer these equations of function notation. Let's do the next one, g of 20. So if we write g of x right underneath, we can tell that that 20 is replacing the x. So if we graph this in our calculator, we're looking for when x is 20. What is our y? Sometimes it is as easy as just typing it in, going to the table and finding the answer. Other times you could just also do it algebraically as well. So if you're doing it algebraically, you're replacing the x with the number, and then doing this with PEMDAS. So 2 times 20 is 40. And then 40 plus 7, that's 47. And then you could just type 6 times 47, and it gives you 282. We could also do the graphing. Let me just clear this. And we type 6 parentheses 2x plus 7. Go to table, and then we find out when x is 20. 282. We could have also traced, but I'll teach you tracing later. So 282 is your answer here. All right, so to speed this up, once again, you're recognizing your function and either substituting the value given for x in for x. So we're going to write 11 squared plus 1 plus 16, typing that in the calculator correctly, or doing PEMDAS and answering this correctly, or just typing this function in here carefully. So 5 parentheses x squared plus 1, close the parentheses, plus 16, and it gives you a graph that you can't see, but it's in there. And then when you do control table, it gives you the table of values. So then you look for when x is 11, and that is 626, which is right there. Or once again, you could have typed it as 5 parentheses, another parentheses for replacing or substituting the 11, squared plus 1, get out of the parentheses and add 16. So that's 626. All right, we'll have 1 minute left before the bell rings. Keep doing that, replace it in there. And let's do this here. So we're gonna do 1/3 parentheses 4 minus our 16 squared. The answer is 48. So algebraically or graphically, just try to find that answer. Before I wrap it up, I just want to talk about this. This is still following f of x. So all these values on the inside are x values. And what you're doing is you're answering if you had a point in the form of xy when x is -2. When x is -2, where is there a point? Right here. So that's -2, comma 3. The y value is 3. So the answer to this will be 3. And if you continue that pattern when f of x, that means when you have a point with the x of 0, 0 all the way up here. So that will be 0, 5. The answer is 5. F of 3 is when the x is 3. So 1, 2, 3, go all the way up here, and that is 8. So 3, 8. And the last one is when f of 5, which is way up here, so the answer is 10. All right, I hope this video helps you. I believe there was one more, but I think by now you know what to do, and I also ran out of time. So I'll see you guys in the class.